No way! Welcome. All right. So what we talked about towards the end of last week was that there are some times that you have imaginary numbers. Let's say we wanted to write out. Let's say we wanted to write out the polynomial least degree that has the following considerations. Remember, if your 0 is at -3, what's your term? X plus 3. And then, just for a quick example, if it was a 2i, what else would there have to be? A negative? There has to be a negative 2i because remember, imaginary numbers always come in pairs. Okay? You can't have one without the other. But what I want to look at today is that. Okay? I was going to yell at you, but I figured I would. I already yelled at other people. People told me I was mean. So when you have this 2 plus I. 2 plus I is the standard form of a complex number. Complex numbers can be written in the form a plus minus bi. That's all that means. That's just a complex number. It's a complex number that happens to be imaginary through that. Now, obviously, whenever an imaginary number comes around, that means that there had to have been a square root taken somehow, somewhere. Which meant that if there was a 2 plus I, what else should there be? 2 minus I. So I just wanted to show you that a lot of times textbooks, they only write out one of them. Doesn't matter which one they write out, but they're probably just going to write out one. Okay. Now, think about the way that we worked with zeros in the past. This one gives me 3 zeros. What should my degree be when I'm done? Should be something to the third, okay? Now, in order to figure out my zero or my term for the -3, we already said that the zero is -3, so the term would be x plus 3. Now, the reason why it's x plus 3 is because technically you did this. Minus a negative, and you wrote it as plus, correct? Now, here's where things start to get a little bit weird. But the imaginary stuff is a complex number. You still write it as x minus a complex number. So it looks like this. It's going to be x minus your complex number and x minus your complex number. You get that. All I'm doing there is writing it like we would, writing it like we would normally for any other term given some sort of zero. In this case, my zeros are at 2 plus I, 2 minus I, so I write it as x minus 2 plus I, x plus 2 plus I. So as you get into this then, the next little scenario that I would worry about is that I would distribute my negative. Okay? Bear in mind this x plus 3 is still here. I'm just going to leave them there, and I'll just bring them down at the end. We'll go through it. So I'm going to distribute this negative to both parts. I'm going to get x minus 2 minus I, x minus 2 plus I. What's that? This 2 here is a positive, so it becomes a negative one there. Okay. Now, the way, you guys remember the associative property? Associative property means how you associate in groups, how you can put parentheses around things. So it doesn't matter if I do this, does it? Did I change anything? All right, now I'm going to show you this little trick that we use in math because, you know, nothing is great about math. Well, this is one of the cool things about math. When you don't know what to do, you make something up. For example, I'm going to use something called U substitution. I'm going to let U equal x minus 2. What's that? Yeah, well, I'm going to, so take it. Now watch what happens. We now get this. U minus I, U plus I. Yes, ma'am? You can use parentheses. All I know is that I had parentheses in there because I let the parentheses part was the x minus 2, but I still have brackets on the outside. I just didn't feel like, usually if I change it to parentheses, people go, what happened? That's why I just left the outer brackets the way they were. Okay. Well, what happened was I let u equal x minus 2. And I put the parentheses around it to show I'm letting all of that equal the u value. What does that look like now? It's not junk squared. It's a difference of squares, isn't it? So as you FOIL that out, then you get a difference of squares. So if you FOIL this, you get u squared minus I squared. What was u in this problem? Now, you FOIL out. Don't kill a puppy. FOIL out. X squared minus 4x plus 4. And what's minus I squared equal again, remember? Plus 1, very good. So way back up on the top, we had this x plus 3. Well, that was a long time ago. So when you multiply all that out with the imaginaries, you're using this little trick called u substitution. Taking something that looks like crap and making it look really easy. Sir? What was u? The reason I wrote u squared minus I squared is because the bracket parts there, if you FOIL it out, it's a difference of squares. Okay, that's where that came from. And then I just FOILed it. X minus 2 quantity squared is x squared minus 4x plus 4. Minus I squared is plus 1. Rewrite it. And now all I have left to do is FOIL that, or not distribute that out. And with any luck, you get x cubed minus 4x squared. Excuse me. Plus 5x plus 3x squared minus 12x plus 15. Polynomial of least degree. Will give me that. So what we're doing here, guys, is we're using this little trick called u substitution. I would say that we'll probably use that trick half a dozen times or so in this class. You use it a ton in pre-calc. It's an awesome little trick to remember for things when things look really, really, really bad. Let you take care of it. Okay. Let's try another one. It wasn't too bad, was it? But that's the thing, and that's kind of the reason why I didn't want to get into that on Friday when I had, 10 minutes left? That's a little bit much for 10 minutes to try to finish that out. That's why we stalled on that part. For example, polynomial of least degree with zeros of 1, 2, and 1 plus I. Polynomial of least degree with a 1, 2, and a 1 plus I. Correct, because you can't have one without the other. That's the idea. You can't have one of them without the other. Yes, ma'am? Nope. I'm not going to tell you how to do anything. I'm just going to say write the polynomial of least degree with the following zeros with a leading term coefficient of 1. Or I could say, and leave out that leading term coefficient. Remember we talked about that? Let's say even a 0 of 2/5. Yeah. It could have been 2x minus 5. Yeah. Or, I'm sorry, 5x minus 2. We can remember that. I'm trying to keep talking to you so I can know what else is. Anything else going on? Did you have a good weekend? Yeah. Better? Dickie, did you play golf this weekend? Why did you play golf this weekend? You should keep your lights out. You don't have time. You're a teenager. That's all you do. You do nothing. I'm joking. I know you guys are all busy. You played golf this weekend? Nice. I shoot. Nice. We're shooting. Where? No? All right, should I help Ashley now? No, because she told you what to say. You are no longer in my good graces. Go away. What do you want? Oh yeah, we're going to test on Friday. We're done. We're done with this stuff. No. Sir. I can't understand you. I don't know. Find something. So when you write this one out, remember the trick will be that there has to, if you have one of them, you have to have the other. Okay. So this will have to wind up being a fourth degree polynomial. Now the first ones are easy. X minus 1, x minus 2. That'll generate x squared minus 3x plus 2. Quick and painless on that part. You don't have to worry about too much stuff at that. Okay. The second part is where it takes a little bit longer to go through. Remember, that's going to be x minus the quantity 1 plus I. And x minus the quantity 1 minus I. And quite honestly, if you did the u substitution once, you probably don't need to do it again because the pattern that evolves. Okay? Because it's the same pattern every time. You get x minus 1 plus I. X minus 1 minus I. If I use u substitution, if I let u equal x minus 1, or excuse me, yeah, x minus 1. Yes, sir. Yeah. If I let x equal that x minus 1, I'm going to get a difference of squares, which generates u squared minus I squared, which is in this pattern, sir. Yeah, I accidentally flipped my signs. I was looking at this one when I wrote this. Yeah, this one should have been the minus, this one should have been a plus. I'm sorry. I was looking ahead of myself when I was doing it, and I just got ahead of it. Hey, that's a dumb right mistake to make because it still works. And again, notice it's the same pattern. It's the exact same thing every time. Junk squared plus 1. It'll be junk squared plus 1. So way up here we had an x squared minus 3x. Do all of it. Approximate a 60-degree angle. Yes. Show me a degree. Show me something. Show me. You got to show me an angle. So this becomes okay. And you go through from there. No, it was a 1. And I just rewrote it. Okay, guys, one thing that you will screw up here when you multiply all this stuff out, you'll forget to add in the 1 here before putting it in. Or you'll think to put it in. So you got to put that in before you multiply everything out. So here it's just multiplying out. This is going to be an x squared minus 2x plus 2. And then you just have to basically multiply out twice. Excuse me, FOIL out 3 times. You have x to the 4th, 2x cubed, 2x squared, plus 3x cubed, plus 6x squared, minus 6x, plus 2x squared, minus 4x plus 4. Partridge in a pear tree. You guys ever do that trick? Underline what you're working on and cross them off as you're going through? Polynomial of least degree. That gets you to that. Good times. All right. That's the last bit of 6-7, which means I can switch into 6-8. Yeah, give me 1 second. Just pull this up real quick. Yeah, it takes a little bit of space on some of those. It takes a little bit of space. Yeah, you'll go through those. You'll go through. I always used an stamp binder, just put paper in it. The 3-ring binder. Are you good, Nelson? Oh, was it? Oh, I thought it was you. Oh, but you were just sitting there chit-chatting though instead, huh? Anyway, so going into 6-8 then, this is actually stuff that you have done. We did this the hard way at the very beginning of chapter 6. Well, we had to figure out what it all meant. So depending upon style of problem or stuff that's given to you or certain situations, in an example like this, if I ask you to graph that, you will. Stand up, use that marker. Try not to hit shift. Good job. I don't know, you just said you couldn't do it, so I'm going to make sure you can. Draw an axis. If by chance you have terms of x minus 2 and x plus 4, where are your zeros? 2 and negative 4. What are your tails doing? They're both up, aren't they? Now, in this case here, you actually have to think about what the tails are doing. It's not written in a foiled out format, is it? But you know that if you multiplied the first terms together, you're going to get what your leading term coefficient is. It's x squared. So it's an up, which just means that it has to go and do this somewhere. You can't graph it. Just graph it. You've done all this. Stay there, stay there. Now what are you going to do? I'm guessing you don't want to plot zeros. Do you need to FOIL it? Where are your zeros? 0. What are your terms? Is there an x? What is that 1/4? It's what? It's like a multiplier. You were saying slope. It's just, think of it this way. If you FOILed all of that out, you would have had terms. You would have had terms that had a GCF of a 4th. You were able to factor out that 4th. It's the common multiplier. It just tells you that your leading, in this case, your leading term coefficient is going to be positive. If you multiplied all this out, well, how many x's do you have? 3 of them, which means how many zeros do you have? What's your degree? 3. What direction are you dancing? Down up. The reason that you're down up is because you have a positive first term, it would be 1/4 x cubed, and it's an odd exponent. So you don't set the 1/4 equal to 0. It doesn't get you anywhere. That 1/4 is just a multiplier. Think of this as this is the factored version of something you've done. This is the easier part. You didn't have to factor to get to this. Okay. Now in this case, you have zeros at -2 and 1. But how many do I have at 1? 2 of them, which means it has multiplicity. So it has multiplicity at 1. Which means, what does it do at 1? It changes direction. Yes, ma'am? No. No, not at all. So if I'm plotting this via my zeros, I know that my tails, well, I shouldn't say the 1/4 doesn't matter. The 1/4 matters in the fact that if you think about the problem, it tells you that you have to be down up because your first term is positive. Okay. So this means that somewhere along the way, it's moving up, it changes direction. Oops. Pay attention to that. It's up, changes direction, and it changes direction at 0 because of the multiplicity. When you have multiplicity of 2, you change direction at that location. Okay? That's what that looks like. That's really all this is. What can you take from the stuff that we've done in the past, which we actually did these problems before, but you had the entire polynomial, you had to factor out everything to get to this part. Today, they're starting at that part and doing the quick graphs off of it. So this is a lot easier. Yeah. Okay. What about this one? F of x is -2 times the quantity x squared minus 9 and an x plus 4. We still have to figure out zeros. We still have to figure out what direction everything's going. We still need to do all that. In this example, what's going to be your degree when you get done? Third degree. And what's going to be your leading term? Negative. How are you dancing? Up, down, because it's odd. We were down, up when we were odd earlier, which means we're up, down now. Okay. So zeros then. Zeros are located where? Yeah, plus or minus 3 and -4. Means we have to move down, change direction, change direction. How many changes of direction does it have? 2 of them. Could you figure out the y-intercept? What would you get for a y-intercept if you multiplied all that out? Seriously? Not 72. Your y-intercept will be at positive 72. How do I know that? Look at your constants. If you FOIL all that out, if you wanted to multiply something together, you'd have to multiply just the constants, your integers. -9 times positive 4 is -36. Times -2 gives you 72. So little things like that, you can still, it's the same idea of why do I know that the first term is going to be x cubed? Why do I know that my leading term here will be 2x cubed? Oops, jump, and then plus the 72 at the end. I know that that's what the bones of this problem would look like. I know that's what the front and the back would do, because that's what it has to be. Okay. Yeah. Oops. This was it's f of x. I'm trying to. One last one. The last little bit of tomorrow I won't be around tomorrow because we got the math team competition stuff. So we'll be out tomorrow. Wednesday when we get back, we have section 6.9. That has another, you know how we did stuff with what do you call them? Quadratics, where you wrote the equation given specific points and stuff like that? Well, we kind of do the same thing with polynomials. It's a super easy process to do so. Sure. Multiply. Yeah, that's implied that they're being multiplied together. I think when I wrote it, I might have sneezed or something. All right. Now, when you go through this, what's going to be the degree of the polynomial? 4. It's going to be a 4th degree polynomial. Okay. What's the leading term going to wind up being? It's going to be -3. So what are your tails going to do? Down, down. He's going to be down, down. Because you have 4 zeros, because you've got squared and squared. Your leading term coefficient, that scalar multiplier, or GCF, if you multiply everything out, would have been a -3. So your first term would be a -3x to the 4th. Down, down. I have duplicated zeros at -2 and -2 and 4. These guys both have multiplicity of 2 for both of them, which means what happens to this graph? Well, not change direction. It's still it touches the 0. It touches those values both once. It changes direction at both of those spots. So at -2 and 4, it comes up, changes, comes up. Oh, Devin, are you going tomorrow? You gotta bring your permission slip to the high school, okay? Bring your permission slip. Oh, okay. You're the best. Are you coming to the high school in the morning? You're coming to the high school in the morning, right? All right, Coolio, bring some food. And that's what that would look like. All right. Not really, because I'm not gonna sit there. I mean, you could figure that out, because if you FOILed it out, you have a 4 and a 16. 4 times 16 is what? 64. 64 times -3 gives you this value down here. Yeah, so this is -172. Not drawn to scale. Okay, that's kind of what we're doing here. You know, it's just like I said earlier. When all things go crazy, just make stuff up. It's like that U substitution. Seriously, it was done by some guy who was stuck, didn't know what to do, and he's like, "I'm gonna let you take care of it." Like, as in, literally let you take care of it. We gotta make T-shirts. We should make T-shirts and like let you take care of it. Why are you talking about drugs? Do those. What's that? Yeah, we'll be back around. We're usually back right around the end of flex, beginning to 12th hour. Oh. Yep. Yep. No, we gotta take care of all the paperwork and all that other junk when we get back up and take care of all that. Both these PDF files are posted right now. They're there. Tomorrow I'll have a couple. I have another worksheet with another handful of problems to get of the same style. Yes, sir. Probably on Wednesday. You'll have the 2 assignments for me on Wednesday then. I will. Hopefully, I should be able to get through. I got to finish up some math team stuff tonight when I get home. But I'm going to try and revamp the the review sheet that I made last year, which was pretty good for this unit. I'm going to retool that a little bit, and with any luck, I should probably be able to post that to you guys also on the calendar. Whether I post it tonight or for tomorrow's, or I might post it to Wednesdays, I don't know. I'll shoot you an email. That way we can get that started through there. But yeah, this shouldn't be a real bad. This hasn't been a real bad unit. There's a lot of stuff going on. But as you go through a lot of the stuff, it's all built to get you to 6.7. 6.7 was kind of the kicker of everything. Everything else kind of led you to it. Okay? Here's this worksheet. So I think I already have it posted. I think I already posted it. Didn't I? I don't know. I should. No, I did not. I do that still.